हेलो दोस्तों। हेलो माय स्टूडेंट्स। बहुत बहुत स्वागत है आपका हमारे यूट्यूब चैनल डॉक्टर मैथ्स में। ये हमारे चैनल का पहला वीडियो है एंड टू स्टार्ट द वीडियो आई विल गिव यू माय इंट्रोडक्शन। माय नेम इज़ संदीप पालियान एंड आई लिव इन न्यूजीलैंड। आई एम अ डायरेक्टर ऑफ small software consultancy company that started by me 8 years ago. कंपनी बहुत अच्छा चल रहा है, everything is fine, but there has always been a deep desire in me to teach the students some concepts of mathematics. In whatever way I can help you guys with mathematics, that'll be a great achievement for me apart from my financial success in my career. तो पहला जो हमने वीडियो या आप कहें कि एक सीरीज़ बनाने का सोचा है, वो सीरीज़ होगा NCERT बुक chapter, all the chapters from class 10 mathematics, and I'll try to make sure, I invest at least 6 to 7 hours a week. So आप लोग होप कर सकते हैं कि 5 से 6 वीडियोस हम एक वीक में ज़रूर कवर करेंगे. And we'll try to complete the syllabus as soon as possible. And after we have completed all these videos, I'll pick around 10 to 20 students for the next session and I'll teach them for free. But the classes would be only on weekends because that's when I can actually assign some time, and I'll make sure you guys score fantastic numbers in mathematics, and not only score, you guys gain some good understanding of mathematical concepts, because I can assure you, लोग कहते हैं कि हमने जो पढ़ा उसका इस्तेमाल नहीं होता, कुछ समझ में नहीं आता, हम क्यों मैथमेटिक्स पढ़ रहे हैं, हम क्यों हिस्ट्री पढ़ रहे हैं, क्यों फिज़िक्स पढ़ रहे हैं, क्यों केमिस्ट्री पढ़ रहे हैं. ऐसा नहीं है. जिन लोगों ने कभी कुछ नहीं पढ़ा, जिन लोगों ने कभी कोई सफलता हासिल नहीं की, जिन लोगों ने प्रोफेशनल करियर्स नहीं बनाए, सीरियसली उन लोगों को इस बारे में कहने का कोई हक नहीं है. आप अच्छे से पढ़िए, अच्छे से कॉन्सेप्ट्स को समझिए, तभी आप जानेंगे कि इसकी कितनी एप्लीकेशन है. आजकल मैं देख रहा हूँ कि लोग ट्रेडिंग में दिन रात लगे हुए हैं. ट्रेडिंग, इंट्राडे, पोजिशनल, swing trading. Even there, people who has got good fundamental mathematical concepts, they can create awesome algos and they can mint a lot of money. So that's just one example, but this is not the example I should give you, but this is something that is actually motivating our new generation. So I just ended up giving this example. But aviation, space, you look at Elon Musk, mathematics used everywhere. Even when you go and ask for purchase anything, you use the mathematics, right? आप बाहर जाते हैं, बोलते हैं कि भाई 1 किलो चीनी दे दीजिए. That 1 kilo is a mathematical measurement unit, right? If we do not have any unit, then you cannot go and shop something. Even in the barter system in old days, we used to use mathematics, right? Okay, ज़्यादा बात नहीं करते हैं, सीधा we deep dive into our first lecture, that is class 10 maths, and this lecture is about the real numbers. So जब आप रियल नंबर के बारे में पढ़ते हैं तो आप सोचेंगे what are the real numbers? The basic simple answer is any number that can be represented on the number line is a real number. And mostly there are two types of numbers, rational, irrational numbers. Both are real numbers. So rational numbers that can be represented in the form of P upon Q, where P is an integer and also Q is an integer and Q is not equals to 0. That's where you say P upon Q is a rational number. Irrational, underscore 2, underscore 3, underscore 5, underscore 11, all these are irrational numbers, right? So all these numbers, minus 1, minus 2, minus 3, all these are real numbers. So real numbers has got a lot of applications. As I said, in measurements, when you measure something, let's say you say my house is 120 kilometers far away from Delhi, that means you are actually using the real numbers. You are telling someone that this is the distance that I'm going to cover if I want to start from Delhi, center Delhi, let's say some point in Delhi, and I want to reach to my place. So this is one of the applications, labeling, measurement, calculations, everywhere real numbers are used. We can even go and talk about a lot more in detail, but my main focus is to cover your chapters, and then we'll have some extra videos or extra sessions where we can talk about the real life applications of the things that we're going to study, and we can take a deep dive. But just for the sake of covering this chapter, let's move on to the next topic. So there is a fundamental theorem of arithmetic that says every composite number, means every real number, I would start with the composite number. Any composite number can be expressed, means expressed, or you can derive the factors of that number as a product of primes, means the factors would be the prime numbers, and that combination would be only one possible combination. There cannot be any second or third combination. Sequence does not matter. This is only the product of primes. So every composite number can be expressed as a product of primes. So let's just start with an example. So हम पहला example लेते हैं 15, right? And you guys know the factors of, I'm sorry about this. So factors of 15 are 3 by 5. So if you see, first off, okay, let's cover what is a prime number. Anyone? So prime number is a number that has factors, and one of the factors is the number itself, and apart from that number, there's only another factor, that is 1. So if you take 2, 2 can be written as 1 multiply 2. 3 can be written as 1 multiply 3. So there's only one factor apart from the number itself, that is 1. So all these numbers are, or you can say ये नंबर किसी और नंबर से डिवाइड नहीं हो सकते सिवाय अपने खुद से, right? So if you take 5, so 5 can only be divided by 5, or it can be divided by 1. It can never be divided by any other number, right? So these are called the prime numbers. And the theorem of arithmetic, the fundamental theorem of arithmetic says any complex number can only be expressed in only one possible way, as a product of primes. So, and sequence does not matter. So if you see 15 का जब हमने फैक्टर किया तो 15 का फैक्टर 3 and 5, 3 और 5 और 3 और 5, 3 is a prime and 5 is a prime number. Let's take another example. Let's say 21. So we know if 21 has got two factors, 3 and 7, and by the definition of prime numbers, you know that 3 is a prime number, 7 is a prime number. You write it as 3 multiply 7 or 7 multiply 3, the result gonna be the same. Apart from that, let's take some more examples. Let's take a bigger number, 1120, and now try to calculate the factors of it. So we put 1120. So first prime number, because we are going with the fundamental theorem of arithmetic, so we'll pick the first prime number. And the first prime number by the definition is 2. So जब हम इसे 2 से डिवाइड करेंगे, let's speak in Hindi also, 2 पंजे 10, 2 चिक्का 12, and then 0, right? Then again we divide it by 2, 2 2 ja 4, 2 8 ja 16, and the remainder is 0. The next digit that we drop down as 0, 2, 140, 2, 70, 2, 35. The next prime number that we can think of can be 3, but 35 is not going to be completely divisible, divided by 3. So next prime number is 5. So 5, 7 ja 35, and then the next prime number is 7. So 1120 has got the factors 2, 1, 2, 3, 4, 5. 5 times 2 multiply 5 multiply 7. तो अगर आप इसे देखें तो 1120 is a composite number, and that can only be written as a product of primes in one possible way, right? So 257, no matter if you write it like 5 multiply 7 multiply 2 raised to power 5, or you write it like 7 multiply 2 multiply 2 multiply 2 multiply 2 multiply 2 multiply 5, result is same. But the essence is a complex number can be written as a product of primes in one possible way, right? इस चीज़ को आप थोड़ा सा समझने की कोशिश करें. बट नाउ what can be the application of this theorem, right? So application, if you go by your book, there's there's a example given there that says check whether there's any value of n for this number 4 raised to power n, and it says check whether for any value of n like 4 1 4 raised to power 2 4 power 3, for any value of n can this digit ends with 0. So if I write it 4 raised to power 4, then it will be 256. If I write 4 raised to power 2, then it will be 16. But this is never ending with 0. But how would you prove that? You can actually prove it via the concept of the fundamental theorem of arithmetic. Now, fundamental theorem of arithmetic says a composite number can only be written as a product of primes in one possible way. So the product itself, the number itself is 4 and it has got two factors, 2 by 2. So it can also be written as 2 raised to power 2n, means the only prime number as a factor that will come for this number will be 2. But you know, if a number has to end with 0, it should have a factor as 5. I'll prove that. If you multiply 2 by 5, then it will come down 10, right? So that means if 5 is not one of the factors, it's never gonna end it with the digit 0, and this fundamental theorem of arithmetics prove that. Because as per this theorem, there can only be one possible way a composite number can be written, expressed, or solved as a product of prime. So as per that definition, the product of prime, the only prime number is 2. This number can never has 5. Hence proved this number for any value of n can never end with the digit 0, right? So this is, smartly you can actually use the theorem. I'm sure they can ask question in your board exams and then can ask you to prove, hey, can you prove that this number 6 raised to power n for any given value of n can never end with 0? So I'm sure you should be able to actually use this theorem, give the reference of this theorem and prove that, right? Now, there's another application of this fundamental theorem of arithmetic is to find the LCM and HCF. Cool. So what is LCM? Very easy. देखिए बच्चों, कभी भी आपको मैथमेटिक्स में कॉन्सेप्ट्स को याद नहीं करना है, आपको कॉन्सेप्ट्स को समझना है, आपको टर्म्स याद करने हैं, आपको पता होना चाहिए किस टर्म का मतलब क्या है. What is the meaning of LCM? What is the meaning of HCF? And I'm sure if once you understand this, you would never ever forget how to calculate LCM and HCF. I'm gonna tell you today one way of calculating LCM and HCF. There's another way of calculating HCF as well, but we'll talk about it later. Today we'll apply fundamental theorem of arithmetic and calculate LCM and HCF. And as I said, never ever try to याद नहीं करना है, कि LCM कैसे निकालेंगे, HCF कैसे निकालेंगे, समझना है तो आइए समझते हैं। LCM, what is LCM? Least common multiple. HCF, anyone? Highest common factor. Okay, so let's take an example. I have got 15 and I have got 25. मेरे पास ये दो नंबर है, मुझे इस थ्योरम का इस्तेमाल करके पता लगाना है कि इन दो नंबर्स का हाईएस्ट कॉमन फैक्टर क्या होगा। तो हाईएस्ट कॉमन फैक्टर मींस हमें एक ऐसा कॉमन फैक्टर निकालना है कि उस फैक्टर से इन नंबर्स को कंप्लीटली डिवाइड किया जा सके, एंड दैट शुड बी द हाईएस्ट common factor among between these two numbers. So first we will create factors of this number. So as per the theorem, you can only divide or express this number as a product of primes in one possible way, and that's this way. 3 multiplied by 5 is 15, and for 25 I'm not gonna go into too detail how you calculate the factors, etc. You guys are smart enough. I'm assuming students who gonna watch my videos have gone through a very good journey in their life and now they want to acquire some knowledge. Don't worry, अगर आप कहेंगे कि हमें बिल्कुल बेसिक्स बताइए, प्लीज़ लीव इन द कमेंट्स. आई विल ट्राई टू कवर दैट इन every possible way. I'll devote more time because as part of the social corporate responsibility, this is one of my ways to help students that gonna shape the future of India. Okay, so अगर आप देखें तो इसमें कॉमन फैक्टर आपको कौन सा दिखता है? कॉमन फैक्टर इज 5, and the highest common factor, highest repetition that is common across these two numbers is only 5, right? Because आप देखें 15 को आप 5 से completely divide कर सकते हैं. 5 3 या 15, remainder is 0. 5 से आप 25 को completely divide कर सकते हैं. 5 5 जा 25 and the remainder is 0, right? आपको ये कॉन्सेप्ट बिल्कुल क्लियर है. हाईएस्ट कॉमन फैक्टर, फर्स्ट क्रिएट फैक्टर्स, देन पिक द कॉमन हाईएस्ट फैक्टर, राइट? जब आप कॉमन हाईएस्ट फैक्टर पिक करेंगे, दैट्स योर आंसर बेसिकली. नाउ लेट्स टेक अनदर नंबर. लेट्स टेक 42 and maybe 24. 42. So 2 multiply 3 multiply 7. Okay, I'll go with basics. 42. First prime number as per the theorem is 2. So 2 2 ja 4, 2 1 ja 2. Now this number cannot be divided by 2 because the last digit should be a even digit. It's an odd digit. So we'll take another number, next prime number, that is 3. 3 7 ja 21. Now this number is a prime number, so it can only be divided by 7, and 7 1 ja 7. So the factors are 2, 3 and 7. Similarly, we'll calculate the factors for 24. So for calculating the factors, we'll start with 2. 1 ja 2, 2 2 ja 4, 2 6 ja 12, 2 3 ja 6 and 3 1 अन्ना 3. तो आपके फैक्टर्स हुए 2 multiply 2 multiply 2 multiply 3, right? And now if you look at it, 2 is common, right? It has got 3 repetitions of 2, but it has got only 1 repetition of 2. So the common factor will contain 2. And the next number 3, is it common? Yes, that's one time and that's one time. Because it's one time here, it's 3 times, but the common occurrence is only one time. So we're going to pick 1 time 2, 1 time 3. 7 is not a common factor, right? So 2 multiply 3 is 6. 6 is the highest common factor. And how do you prove it's a highest common factor? First off, if it is a factor, then then these two numbers should be completely divided by 6. So we take 42. So we all know by the table 6 7 ja 42 and the remainder is 0. And when we take 24 and 6 4 ja 24 and the remainder is 0. So this is how we have calculated highest common factor. Now let's go and calculate the least common multiple. So we know 42 has 2, 3, 7 and 24 has 2 multiply 2 multiply 2 multiply 3. Right? Now as per the definition, what is LCM? LCM is a least common multiple. What is it? Least common multiple. Now that means we need to find out a number. What is that number? X that can be completely if we assume A is 42 and B is 24, then we assume that X can be completely divided by A and X can be completely divided by B. When we say completely, means the remainder would be 0. Remainder would be 0, right? And that is the least possible number. That they can be number, once you find out the number, you can even go on multiplying that number by the factors. So you can continue counting a lot more number till infinite, but we are interested in the least possible, the first number in the sequence that can be divided by these two numbers. So we'll go with this theorem of arithmetic. The approach is slightly different. So we'll find a number. We'll start with 2. So 2 appears one time here, but it appears 3 times here. So we'll take the highest occurrences. So 2 multiply 2 multiply 2. The next number is 3. It repeats one time. It has got one time only here. So only 3 to the power 1. So we go 1 time 3. And there's a 7 here, but not here. But still it is one of the factors. So we'll take it as 7. You just need to understand this, right? So what we have done, we have taken the highest occurrences of the factors from these two digits. And no matter if that number is not a common, because we're not finding the common, we're finding the multiple. So we take this number 2 3 times, then 3 and then 7, multiply it. 2 दूनी 4 दूनी 8 तिया 24 multiply 7, and then how do you multiply? 7 4 ja 28 power 2, 7 2 ja 14 to 148. So 148 is the least possible multiple and the least common multiple of these two numbers that can exist. Let's prove that. So in order to prove that, we'll take 148 and then we divide it by 42. So how do you divide it? The many ways you can divide it. So what you can do, 148 upon 42, you can divide it by 2. 2 7 ja 14 and 2 4 ja 8, 2 21 times. And then if you go, you can say, oh no, yeah, that's right. Then you can go 3 is the next number that you can use. Now, oh, have you committed any mistake here? Oh, that should be 168, right? Yeah, that's what I was wondering. I mean, this is wrong calculation. Sorry, guys. So this should be 168 is the least common multiple. And now we go and sorry about that. Extremely sorry about that. So I'll remove this number and then we'll start again. So 168. So we'll go 168 divided by 42. So first 2, 2 8 ja 16, 2 4 ja 8, 21. And now you can see 21 4 times 84. So 168 is completely divided by 42. And the same, if you look at the other number, that is 24. So 168 divided by 24. So you can go the same way. 2 8 ja 16, 2 4 ja 8, and 2 12 times. And you can, if I can just jump it, but let's say 2 4 ja 8, 2 2 ja 4, 2 6 ja 12, and then it's completely divisible 7 times, right? Or if you want to go pretty basic, you can also write the factors. So there are many ways. I'm sure you guys are way smarter than our generation, so you know how to calculate the factors. So you can say 2 8 ja 16, 2 4 ja 8, 2 4 ja 8, 2 2 ja 4, 2 21 times, 3 7 times. Then you have the factors 2 multiply 2 multiply 2 multiply 3 multiply 7. And then for 24 you have 2 multiply 2 multiply 2 multiply 3. So they completely divisible, and then the answer is 7. So this is one of the ways we have actually calculated LCM and HCF, and this is via the application of the fundamental theorem of arithmetic. तो स्टूडेंट्स, आज हमने कवर किया व्हाट आर द रियल नंबर्स, एंड उनका रियल लाइफ एग्जांपल हमने कुछ बातें करी उस पर. I hope you guys will go back to the book, try to go through the book, the chapter, read it in detail, come back to the video, leave the comments, because see, I've done a lot of teaching. I do the corporate teachings as well. I actually discuss, share my knowledge with my teammates in my company. I've always been doing it during my school days, during my college days. But a teacher can never be perfect. A teacher can never get the feedback until his or her students give him the right feedback. आप लोग मुझे अपना feedback दीजिए. आपको जिस तरह से और improvement चाहिए videos में, I will try to incorporate that, and I will try to make sure you guys get the maximum return on the time invested on these videos. Thank you very much. So today we understood real numbers, we understood the theorem, fundamental theorem of arithmetic, and we did talk about the two applications of this theorem. Pehla application tha how you can prove that a number can never end with the digit 0. With the prime factorization method, we proved that. And the second application is to find out the LCM and HCF. And remember, कभी भी हमें ये याद नहीं करना है कि LCM कैसे निकलेगा, HCF क्या होता. आपको सिर्फ टर्म पता होना चाहिए, कॉन्सेप्ट आपके दिमाग में खुद से ट्रिगर करेगा. ओके, ऑलराइट स्टूडेंट्स, सो सी यू